In this video, we're going to cycle back to linear functions and we're going to do more applications and have a good solid review. It's a good time for you on your own to go back and review any of the prior skills that you struggled with and go back over your prior tests as well. So linear equations you've done before, and we're going to go a little deeper. We're going to use some function notation and other things that you've learned along the way, and also dive in to some more word problems. So a lot of this is going to be kind of review, so I'm not going to go through too much of it. We are going to look at transformations with linear functions as well, which are just straight lines, but we're going to see how they move, how the lines move. I'll probably put up some things from Desmos either in the Canvas course or we'll do an activity Monday on that. So to start out with, I just want to do a little review of graphing linear equations. So these are some notes condensed down for you. The equation form y equals mx plus b is the same with function notation. We just call it f of x equals mx plus b. We have increasing function from left to right, decreasing, and a constant function goes just straight across there. And vertical shift, we're going to look at, let me blow this up a little bit here. Vertical shift in f of x equals mx plus b. The b acts as the vertical shift. So that's your up-down movement without affecting the slope of the line. So if we look at this figure below, we are going to have our parent function is basically the plain one, this one right in the middle that I'm circling, f of x equals x. That's also your line of symmetry when we are talking about inverse functions, which we'll get into in Math 141. So if we look at this red line, we have f of x equals x minus 2. So that means my original point that was at the origin on my parent function, f of x equals x, shifted down 2 units. This dark navy blue, f of x equals x plus 4, you can see that shifted up. So it's like basically you're taking that whole line and just moving it up. That's what a transformation is. We also could shift to the left or right if the x is affected, but that gets a little trickier. So we'll get into a little bit of that later. Stretches and compressions are over here. That's when we have, like, we're multiplying it and our slope is going to change there on those. So if you can see, the parent one is right in the middle here. I'm highlighting it. F of x equals x. And then if we have a steep slope like this, f of x equals 3x, that is a stretch. And here's a compress down here with a fraction. So we'll talk a little more about that later. So for each problem, use a graph of the linear function to help you answer the question. So number 1, determine whether the function is increasing or decreasing. Now you can just look at the function itself and notice what the slope is doing. So we have n of x equals negative 1/3 x minus 2. We can also graph that really quick to have a review of graphing. So I'm going to do that right here. I'm going to plot my y-intercept, that negative 2. That's my shift down. And my negative 1/3 tells me to go down 1 over 3, down 1 over 3. Or I could do the exact opposite, up 1 and then left 3, up 1, left 3. And I've got a pretty good spread there, so I'm going to go ahead and connect my dots. I don't have a ruler on this app, but you should use them when you're doing it on paper. So this is decreasing. And it is a function, so we'll say it's a decreasing function. And remember, we read graphs left to right in general. So number 2, find a linear function satisfying the conditions f of -1 equals 4 and 5, or f of 5 equals 1. So my input is -1 comma output 4 for the first one. So get used to thinking of those in terms of points, like an f of x equals y situation. So then we would have the point 5 comma 1 for the other pair, coordinate pair. You can go ahead and just graph that if you wanted to. You can figure out slope, average rate of change. Actually, average rate of change is the same as rate of change in this case, ROC, but we can just refer to it as average rate of change, AROC, as well, just like you did before, even though it's a straight line. So you have learned those skills and you know how to figure out how to write an equation of a line. That's review, but now we're doing it in function notation. So go ahead and see if you can work that out on your own as a try it, and then come back and see what the answer is. So to save time, I've just started some of this. The average rate of change, or AKA M, for our slope is f of 5 minus f of -1, all divided by f minus -1. To figure those out, my f of 5 is given as 1, minus the f of -1 is given as 4, all divided by 5 plus 1, because I have that double negative there, equals -3/6, and always reduce your slope. So I get -1/2, and then I'm going to just pop that in for m right here. And now I have f of x equals -1/2 x plus b. I can put in one of the points to figure out what b is. I don't know that. I don't have any info to help me, but I can put the 5 in for x, and I can put this 1 in for y, or f of x. Okay, so I'm going to go ahead and write that up. So I would have 1 equals -1/2 times 5 plus b. You could have chosen the other point, would have been totally fine. It doesn't really matter. And then I would end up getting 1 equals -5/2 plus b. And I'm going to now add that 5/2 to both sides. Good fraction work here. So when I do that, I'm going to end up with 2/2 plus 5/2. So I need a common denominator equals b. So therefore b is equal to 7/2. Now I can write that equation out, or function out, as f of x. I'm just kind of taking this one here and filling in b. F of x equals -1/2 x plus 7/2. And that is my linear function. I can also graph that. I'm just given the 2 points, so I can go ahead and jot that down so you can see what it looks like. I have a -1, +4, and I have a 5, 1. and just kind of connect the dots carefully there. Usually on a test, I do ask you to label at least 2 points, just so it's clear, because everybody's graphing in different ways. But on this, we're all being consistent. So next thing is a bit of a review on parallel and perpendicular lines. Remember that parallel lines do not intersect. They have the same slope or rate of change, so to speak. If they have the same slope and the same y-intercept, then they coincide. They're the same line. Lines that are perpendicular will have the negative reciprocal will be the slope. So if I have the product of the slopes will be -1, or I could write it this way: m sub 2 equals -1 over m sub 1. So however you like to think of that. So we've done this before with equations. Now we're just using the function notation. Write a function for a line perpendicular to p of t equals 3t plus 4 that passes through the point 3, 1. So remember x, f of x instead of x, y. Sometimes people like to use the y notation instead of f of x to just streamline it, but then don't forget to write it in function notation in your final answer. That's really important for these type of applications. Well, especially when we get into applications. So I'm going to have you try all of these. This really should be review. So pause the video and go ahead and do number 3, writing that function line perpendicular. And then 4 is sketch the graph of each function. You have a is f of t equals 3 plus 2t. B is r of x equals 4. Okay, so I've graphed the p of t function that we were originally given in green here, labeled p of t, just by slope intercept form. Just note that if your slope is 3, you don't have to go up 3 over 1. If you run out of grid, you can go the exact opposite, because -3 over -1 is the same exact thing. So down 3, left 1 can also be done. So I sketched that in, and then what I did was figure out my slope to be -1/3 because it's a perpendicular. So that's right over here. Then I plugged that in for m. I called my function f of t so it's different, and I need to find b. So far I have f of t equals -1/3 t plus b. I've got to figure out b. I can do that because I'm given a point on that line. So 3, 1 is a point, so I put 3 in for t and 1 in for the f of t. And I solve and I get b equals 2. So my function comes out to be f of t equals -1/3 t plus 2. And I can graph that as well. I can graph my y-intercept is 2, and then my slope goes down 1, right 3. Let's try and do that in blue. Let's put that in blue. And then down 1, right 3. I can also go up 1, left 3, and we have a perpendicular joint there on our lines. So that's it for number 3. Number 4 is just sketching a graph. So you want to start to get really quick at this. So f of t equals 3 plus 2t. So we would have our y-intercept is 3. And then I can go up 2 over 1, or I can actually go down 2 over 1, down 2 over 1, and get a few points. Then go ahead and connect. Using a straight edge, you'd be better off to have a nicer looking line there. And then usually with the point slope graphing, you want to label a couple of points. So I would label -1, 1, and I've got my y-intercept there as 0, 3. I can label that one as well, and don't forget to put the arrows. For b, r of x equals 4, that means that the y component, or r of x, is 4 here, there, everywhere. So I'm going to get a horizontal line going across. Now, a vertical line we wouldn't even consider because that wouldn't be a function, right? I would definitely fail the vertical line test. And you can think of the slope as being 0. Sometimes it might even help to think of r of x equals 0x plus 4, although we normally wouldn't write that. We would just write r of x equals 4, like we have above. In here, again, is just calculating slope in general. You may see this kind of notation here, delta y over delta x. That just means the difference or the change in y's over the change in x. That you've seen before, I'm sure. So number 5 gives us find the value of x if a linear function goes through the following points and has the following slope, x comma 2. And we have the other point is -4 comma 6, and m equals 3. So let's see how we can figure that one out. What would be your plan of attack? I guess if you know what the slope is, but you're missing one piece, you can set up your equation, just like above here. We can use function notation, or we can just use m because it's linear, but I know that my m, or average rate of change, is going to be the difference in my y values. So I would have 2 minus 6 over the difference in my x values. So I would have x minus 4. And I'm given that my m is 3, so I'm just going to go ahead and replace that there. Then I just have to do some quick solving. So this becomes a plus. So in my numerator, I will have -4. In my denominator, I have x plus 4. I can clear the denominator. This has a lot of good skills we have learned. X plus 4 on both sides. This reduces out, and then over here I'm left with, on the right hand side, I would have 3x plus 12 equals -4, and then subtract 12 from both sides, and I get 3x equals -16. Divide by 3. X equals -16 over 3, which is kind of not the best number to work with, but it's okay. It's fine. It's we'll deal with that. It's just a fraction. You know how to do it. So that's what we need to plug in for x now. So I'm going to just make a little divider here. And I'm going to write my function again. Up here is going to be, we'll just call it generic f of x equals mx plus b. Now plug in what you have in order to find b. So pause the video, try that. So we do have 2 different points we can work with. We don't have to choose this one that we just figured out the x for. That was just part of the question, find the value of x. So you have that skill, but it's going to be messy to plug in. So I can actually choose the -4, 6 to plug in. That'll be much easier. So I'm going to put 6 equals, and then m was 3 that we were given. X that matches up to the output of 6 is -4 plus b. And then just go ahead and solve that. This comes out to -12. So I would add 12 to both sides. I get 18 equals b. Now just go ahead and put everything back in its generic, like the f of x equals 3x plus 18. And we don't necessarily factor that. It's, you know, just leave it as 3x plus 18 is the form we want. The linear function applications, they kind of roll into 4.2. We'll have some of those, but I want to do more modeling, like some more generalized problems, real data, and some supplemental material. So 4.1 also has just some word problems that were kind of straightforward. So that's what we're going to do here. And I'm going to make a part 2 of this video because I feel like this is just getting kind of long to upload and everything. So I'm going to get that, let's pause here and come back and check out part 2 for this. Although I do encourage you with this one because it is review, just try, you might just do the whole worksheet, the rest of it on your own, and just double check though, like you can skim through the video to make sure you get them right and that you're using the right language. So putting that stuff in everyday language and the function notation is really important. Make sure you interpret your answers in sentences to get full credit on tests. So have a great day. I'll be back in another video momentarily.